Hey everybody, we are going to do lesson 32 today. It's probably one of your least favorite, but it's one of the most important things that we have to understand is how to read expressions, how to write expressions, how to put them together so that we can solve them correctly. A lot of what we are going to do today is just set them up and look at them. You may not have to solve all of them. Maybe we have to solve some of them though. So let's check it out. Our objective is to interpret and evaluate numerical expressions, including the language of scaling and fraction division, which we've been talking about scaling a lot, multiplying by a factor of 1, whether it be 10 tenths or 100 hundredths. And so I have a couple of sample problems. These are from the warm-up in the book. Taking a phrase and figuring out how to write it. So if you have something that in a word problem says, well, this is twice the sum of 3/5 and 1.5, then how would you turn that into numbers? So remember that twice means 2 times. Okay, twice the sum. If I said, let's go to Disneyland twice, well, you get to go 2 times. So just turn that into 2 and a times. The sum is a math word, very important. You have to know that that is the answer to an addition problem. So what are you going to add? You're going to add these 2 things. And when you add them, you're going to put parentheses around them. Now, in the book, a lot of the time, if they have just a 2 times 3/5 plus 1.5, they may not put the parentheses in if they want you to multiply these first. But if you have to get the sum first, then you must put the parentheses in because the sum has to be calculated before you can multiply it by 2. And it's critical. And so there are rules that go with this. It's for PEMDAS. I'll show you that in a second just as a reminder. Now, what can you do about this 2 times? You can do twice the sum. If you get the sum this way, you can have your 2 times first or your 2 times second. You should get credit either way because of the commutative property. I can multiply my factors. The sum of this is going to be a factor, and then here is that factor again. So whether I multiply 2 by the factor this way or the factor times 2 this way, I will get the same answer because the commutative property has proved that. Another one, half the sum of 3/5 and 1.5. The word half means you have 2 options here. You can either take half of, which means 1/2 times, like this, okay? And then here again we have the sum of 3/5 and 1.5. So putting the 3/5 and 1.5 together in parentheses with the sum, okay, then you can multiply by a half. Now what is your other option besides having 1/2 times at the beginning or at the end? When you multiply this, you would find that this times 1 gives you your answer that you would put on top, which you would then divide by 2. So let's say you don't want to multiply by a fraction because you see that you're going to half the sum, and you know that half is dividing by 2. So you could set it up like this, as long as you put the division and the 2 after you get the sum. Okay, the only way you can get this right is to put this first and then divided by 2. You cannot put 2 divided by. That's not the same thing. Okay, then the last one, the difference between 3/4 and 1/2 divided by 3. So first you have to get the difference. Now difference is another math word. That means the answer to a subtraction problem. 3/4 minus 1/2 is what has to be obtained first so that you can actually have the difference. Okay, then when you have the difference, you would divide by 3. This has to be first, then you have to have the divided by, then you have your 3. Okay, now there will be some that you do have to solve or evaluate, means the same thing, just a fancy word. This is probably what they'll use because they love fancy. Okay, so when you do your solution, remember that with addition and subtraction, this is subtraction, you must have common denominators. So now we're going back to Module 3. Must have common denominators when working with fractions. So change both to 4s. Change this one to a 4. Leave the first one alone. 3/4 minus 2/4, that gives you 1/4. Now I can divide by 3, which is really 3/1. Now it's looking a whole lot more like what we've been doing recently. keep it, change it, flip it, so you multiply by the reciprocal and get 1/12. Now there's a wee bit more on the back. Okay, and then I'm going to show you a couple of the posters that you should have. You also have to put things into word form. So taking something that's already in an expression and then writing it. So remember that you've got to get what's in parentheses first. So if it has a subtraction, you want to use this math word, use the difference between 1/2 and 4/10. Now, what are you doing with that? Well, I'm going to multiply by 2/5. Now, you can have the 2/5 first and say 2/5 times the difference, or you could say the difference between 1/2 and 4/10 times 2/5, and it will work either way when you multiply, because you can move the factor to the front or the end. Okay, and then this one is 3/4 plus 1.25 divided by 1/3. So I wouldn't read it or write it like that. I would have to say the sum of 3/4 and 1 and 25/100. So I'm getting the sum first, divided by 1/3. It's got to be in this order. Okay, divided by 1/3 has to come second because you have to get that sum first. Okay, now I'm going to go back to some of the very important things that we had gone over earlier, but if you haven't watched those videos, then you don't have these great posters, what I call them, on the wall, but they're just in our notebook. So if you have your math words, this is what you're going to be using when you are writing your word statements today. Sum is for joining groups or joining unlike groups. Okay, you can put them together. That's addition. Subtraction is separating. Sometimes they'll say using or eating or somebody, 3 people left. That's difference. Okay, repeated addition or multiples is going to lead you to a product. Sharing evenly, key word, and it's going to be the division sign, but you're trying to find the quotient. Use these words in your word writing of the expressions. Next, order of operations. You really need to understand that this has to be the order. PEMDAS, parentheses. We don't really have many exponents in 5th grade, but you will next year in 6th. Multiplication and division have the same power, so then you would operate left to right like you're reading a book. Okay? Addition and subtraction are weaker than multiplication and division, but they also have the same power, so you could have addition and subtraction in any order in your problem. Operate left to right as you solve. And then again, the properties that we've talked about in the past: commutative, associative, and distributive. Commutative means you can move the factors around and get the same answer. Associative means you can group them in different groups and still end up with the same answer. Distributive, we've only done a little bit, and it's taking things apart and then adding them separately, and you put it together and you get the same answer as if you use the standard algorithm. Now that's a lot of notes for today. So we're going to jump into the book. This is page 321, and we'll get going. So at the beginning, we are just circling the expression equivalent to what? The sum, that's going to be a plus, of what? The sum of 3 and 2 divided by 1/3. So there are, a couple different ways, as you saw, that you can write things. So the sum of 3 and 2 divided by 1/3, not divided by 3, divided by 1/3. So this is nice, but this is boo. Nope. Okay. This does not give me the sum of 3 and 2. I'm not going to be working with 3 and 2 here because right here the parentheses say to operate with 2 divided by 1/3. That is not going to give me the sum of 3 and 2. This is the sum of 3 and 2. And then after I get that, I would divide by 1/3. So I'm going to circle the expression equivalent, and that one is equivalent. Now what about this one? I also have the sum of 3 and 2. Okay, that is correct because the parentheses tell me I have to do this operation first. But what about when 1/3 is over on the left? Does that work? No. You cannot move a division part of the expression in the same way that you can move multiplication. Division and subtraction cannot have the same movement principles. It doesn't work for the commutative, associative properties. Okay, it doesn't. So this is not going to work for us. So it's only that one. Next one. Circle the expression or expressions equivalent to 28 divided by the difference, that's subtraction, between 4/5 and 7/10. So I know I need 4/5 minus 7/10, and I have to get that first. So I'm really interested in where the parentheses are. Oops, this one, they've switched the order. You can't, oh, really? A phone call. Nice. There's something interesting every day. 7/10 minus 4/5 is not the same. That's not what that is, okay? So we need to match this one. Then, if I have 28 divided by the difference, then 28 has to be on the top or in front, okay? If it's like behind, that's not what they're saying here. So that one doesn't work, okay? So now let's look at these. 28 divided by the difference between 4/5 and 7/10. Okay, here I have 4/5 minus 7/10, and I have the division, 28 divided by the difference. So this one is going to work. Now with this one, what we really would make me feel better is if they had done this. Now, typically, if you see this, you're supposed to do like division first, but they don't have this. So I don't know if that's like a misprint or whatever, but I would definitely want to have the parentheses there so that you can get the difference before you can do the division. I would never even know how to divide this by like one fraction at a time. Like you just will never see that. So it's like, it just looks weird. So anyway, put the parentheses in and then it is correct if their parentheses are there. So now fill in the chart by writing an equivalent numerical expression. So you're going to read it and then you're going to write what the value is in the expression, okay? So half as much as the difference, subtraction, between these two. So if it's half as much, I have two options. I can do half of the difference between 2 1/4 and 3/8. Okay, so I can do half of that, or you can also do 2 1/4 minus 3/8, okay, divided by 2. I'm sorry, yeah, divided by 2. Okay, you can also do 2 1/4 minus 3/8 divided by 2, like that. Okay, so you can divide by 2 this way, you can divide by 2 as a fraction, or you can just take half of that, really whichever way you prefer. Difference is subtraction between this, and then divided by 4. So we have to, in this order, get 2 1/4, find the difference between that and 3/8, and then divide by 4. If you want to set it up with the fraction form over 4 as well, that's fine, okay, because that is also equivalent. Or this, okay. How about a third of the sum of what? Of this and this, okay? So we're going to put those two together, and then we're going to take a third of it. So you can do a third of the sum of 7/8 and 22. What? They are so trying to mess with us. So 22/10 can look like that, or it's kind of a weird looking decimal, or you can do 1/3 of 7/8 and 22/10 if you feel so inclined. It really is up to you. Whatever you're comfortable with. Oh, look, 22/10 again. Add 22/10 or 2 2/10 and 7/8, and then triple the sum. So when you add, you're going to do the addition first, and then you're going to triple that sum. Okay, so these are ways you can write and get those set up to solve. You don't have to solve them here. This is just getting it ready. Okay, compare expressions 3a and 3b, these two up here. Now, without evaluating, so they're saying just look at them. identify the expression that is greater and explain how you know. So if I look at, because they're using the same numbers inside the parentheses, 2 1/4 minus 3/8, 2 1/4 minus 3/8, which one would be greater and why? So if this one's being divided by 2 and this one's being divided by 4, if something is being divided by 2, then those sections are halves, as opposed to something being divided by fourths. And so these are actually smaller. So the one divided by 4, the greater number, makes a smaller answer. So 3b is smaller because we are dividing by 4, which is bigger. More than 2. Okay, so 3b is smaller. We're supposed to identify the one that's greater. 3a is greater. There you go. That's probably a better answer. Don't tell your teacher I messed that one up. All right, 3a is greater, 3b is smaller because we're dividing by 4, which is more than 2. If you want to flip that around and say 3a is greater because we're only dividing by 2. There you go. Now you have both sides. See, we're so thorough. Okay. Next side, fill in the chart by writing an equivalent expression in word form. So now we're doing words to match what's happening here. Use the math words from that poster that I just showed you. Okay, so I've got to get the sum here before I multiply. I've got to get, we didn't really talk about this much, but when you multiply, you're getting the product there, okay? And then we have to get the difference after we get the product, okay? In parentheses, first, we have to get the sum before we get the product. And here we have the product before we get the quotient, fancy word. So turn these into word expressions first. If I read it from left to right, don't think that's how we're going to write it because that doesn't always work. 3/4 times 1.75 or 1 75/100 plus 3/5. I have to get, you can either do 3/4 the sum, so you can start out with 3/4 of, or just 3/4 the sum, okay, of 1.75 and 3/5. That will work, okay? And since we have 3/4 on the left, you can start out with your 3/4 of the sum. That would be fine. Now with this one, we have to find the product first. So if you want to say the difference between this and the product of this, that's fine. So I would say the difference between 7/9 and the product of 1/8 and 0.2. Okay, so you're finding the difference between this thing here and this whole thing over here. Okay, next one. I would go with the sum of 1.75 and 3/5, and then I would just say times 4/3, or you could say 4/3 times the sum of this. You can switch that around because, again, you can switch the order of the factors. This is a whole factor, and you will get the same answer. The next one is 2 divided by the product of all that. So, and sometimes they actually will let you use these instead of just 2. 2 divided by the product of 1/2 and 4/5. Okay, so you can do that. It has to start with 2, though, because 2, this is the whole. So this is what's being divided. So you have to say what's being divided by. It's not this divided by that. That would make the 2 be on the other side. Okay, let's do a little bit more. Compare the expressions in 5a and 5c without evaluating. Identify the expression that is less. Oh, this time maybe I'm ready. Explain how you know. So 1.75 plus 3/5 is the same. This one is multiplied by a fraction less than 1. This one is multiplied by a fraction greater than 1. We're trying to find the one that is less. So A is less because 3/4 is less than 1. 4/3 is greater than 1. Okay, and you could write a whole bunch more, but since it's getting pretty long here, I'm just going to move on. This is the gist of it. Okay, it's all about the 3/4, so the 4/3. Okay, evaluate the following expressions. This is when you actually have to do the solving. We haven't really done any yet, so try to talk you through it. First, solve what's in parentheses. 9 minus 5 is 4. 4 now divided by 1/3. Turn this into 4/1 because that's a whole number. Keep it, change it, flip it, multiply. 12/1 makes 12. Okay, now this one, we have to solve this. Just ignore what's on the outside of the parentheses until you have solved what's on the inside. If it's on the left, just rewrite it. Ignore and move on. 2/1 times 1/4. Okay, now you can multiply it straight across, or you can cross cancel. I always like to cross cancel before I multiply. That will give me 1/2. Now I have 5/3 times 1/2. And again, I always look to cross cancel, but sometimes you just can't. And 5 times 1 is 5, and 3 times 2 is 6, and you end up with 5/6. And now we've solved that one. And finally, leave this alone until we have solved what is in parentheses. 1/1 divided by 1/4. Okay, this is division with fractions. So I'm going to do, this stays the same, multiply by the reciprocal, get 4/1, which is equal to 4. So now I have 1/3 divided by 4, or 4/1, which we can actually keep the same because we're going to use it here. So keep it, change it, flip it, and we end up with 1/12 there. Okay, hopefully that is all right for you. Top of the next. This is kind of a long one. Hopefully that's the end of that one. Yes, it is. This is the last page. Hang in there. Okay, we're going to continue solving. Now, when they don't put parentheses, what did I tell you to do? I said solve left to right, but we can also group different factors, and we can cross cancel. So when I look at these, I think, I sure see some really easy things to cross cancel. Okay, commutative property tells me I could move the 5 over here and get 1, and I could also move the 3's and get 1. So all these 1's work out to give me 1/2. Now, half as much as 3/4 of 2/10. So let's write that in number form. Half as much as, if I have 3/4 times, what if I just turned it into a fraction? Can I do that? Of course. Okay, and then I can simplify or cross cancel because these are both connected by 2. So 2 goes into 2 one time, 2 goes into 4 2 times. That gives me 3 times 1, which is 3, over 2 times 10, which is 20, and that's what we're going to multiply by 1/2. And I can't cross cancel anything, so it's going to be 1 times 3 is 3, and 2 times 20 is 40. So 3/40 is our fun answer there. And then 3 times as much as the quotient of, remember that's division, of this and this. 3 times as much as the quotient of this and this. Okay, so we can do 2.4 over 0.6. This is what we just did in the previous lesson. You want to move that out so that you get 24 divided by 6, which is then 4. And we're going to multiply that by 3, and we get 12. Okay? And now down to the last few. This is actually pretty quick. So it says choose an expression below that matches the story problem and write it in the blank. It'd be nice if they gave you the story problem first, which is down here, but they don't. So Farmer Green picked 20 carrots. That's the whole. He cooked 2/3 of them and then gave 5 to his rabbits in that order. Write the expression that tells how many carrots he had left. So we can choose from here, but really I'm just going to say, let's look at it and say 2/3 of 20 or 20 of 2/3. It's 2/3 of 20. You could do either way, but this is actually the correct way. And then after you find that, you give 5 to the rabbits. So that is 2/3 of 20 minus 5. Now again, why don't they put the parentheses there? Well, because multiplication has the power over subtraction. So technically, you are supposed to solve this first. I always put the parentheses in just because I don't like to have anything hanging or dangling inappropriately, and I feel like that's not appropriate. Farmer Green picked 20 carrots. Here's a new one. Let's figure out which one to pick. And we should circle that. Farmer Green picked 20 carrots. He cooked 5 of them, so this is going to be 20 minus 5, and then gave 2/3 of the remaining carrots to his rabbit. So write an expression that tells how many carrots the rabbits will get. So we have to pick the 20 and then get rid of 5. So I've got to do a 20 minus 5 somehow first. Now, that's not this one, and that's not going to work here. So now I'm looking at the 20 minus 5. And then gave 2/3 of the remaining. So first I'm going to get 15, and then I'm going to get 2/3 of that. That's this one here. Could you put the 2/3 after? You could, except that they don't give us that option. So, whew, that is this lesson. Be a subscriber and watch these fun videos every day, and maybe the phone will ring, or maybe the lights will go out, or maybe something else will go wrong. There's something almost every day, I'm telling you. Tune in next time. See you on the next one. Bye.